Welcome! This video will provide an introduction to the AWS Lambda service. AWS offers many compute options. For example, Amazon EC2 provides virtual machines, while both Amazon ECS and Amazon EKS offer container-based compute services. However, there is another approach to compute that does not require you to provision or manage servers. This third approach is often referred to as serverless computing. AWS Lambda is an event-driven serverless compute service. Lambda enables you to run code without provisioning or managing servers. You create a Lambda function, which is the AWS resource that contains the code that you want to run. You then set the Lambda function to be triggered, either on a schedule or in response to an event. Your code only runs when it's triggered. You pay only for the compute time you consume. You are not charged when your code is not running. With Lambda, there are no new languages, tools, or frameworks to learn. Lambda supports multiple programming languages, including Java, Go, PowerShell, Node.js, C#, Python, and Ruby. Lambda completely automates the administration. It manages all the infrastructure to run your code on highly available, fault-tolerant infrastructure, which enables you to focus on building differentiated back-end services. Lambda provides built-in fault tolerance. It maintains compute capacity across multiple availability zones in each region to help protect your code against individual machine failures or data center failures. You can orchestrate multiple Lambda functions for complex or long-running tasks by building workflows with AWS step functions. With step functions in Lambda, you can build stateful, long-running processes for applications and backends. Finally, with Lambda, you pay only for the requests that are served and the compute time that is required to run your code. Billing is metered in increments of 100 milliseconds, which makes it cost-effective to run code on AWS Lambda. Lambda functions are triggered by event sources. An event source can be an AWS service or developer-created application that produces events that trigger the AWS Lambda function to run. Some services, such as Amazon S3 and Amazon CloudWatch events, publish events to Lambda by invoking the Lambda function directly. Other services are pulled by Lambda. For example, Lambda can pull records from an Amazon Simple Queue service, and Lambda can read events from the Amazon DynamoDB database service. Finally, some services, such as Elastic Load Balancing and Amazon API Gateway, can invoke your Lambda function directly. You can also invoke functions directly from the Lambda console or via API, SDK, or the AWS CLI. Direct invocation can be useful. For example, when you are developing a mobile app and want the app to call Lambda functions. AWS Lambda also automatically monitors functions by using Amazon CloudWatch to assist you to troubleshoot failures in a function. Lambda logs all requests handled by your function. Now that you know that a Lambda function is a custom code that you write to process events, and that Lambda runs the Lambda function on your behalf, let's consider how you configure Lambda functions. When you use the AWS Management Console to create a Lambda function, you first give the function a name. Then you specify the runtime environment the function will use. For example, a version of Python or Node.js. You also specify an execution role to grant IAM permission to the function so that it can interact with other AWS services as necessary. Next, you configure the function. Configurations include adding a trigger. You specify one of the available event sources. Add your function code, either by using the provided code editor or uploading a file that contains your code. Specify the memory in megabytes to allocate to your function. Optionally, specify environment variables, such as timeout, the specific VPC to run the function in, and other settings. All of the settings just mentioned end up in a Lambda deployment package, which is a zip archive that contains your function code and dependencies. When you use the Lambda console to author your function, the console manages the package for you. However, if you use the Lambda API to manage functions, you need to create a deployment package yourself. Consider an example use case for a schedule-based Lambda function. Say that you're in a situation where you want to reduce your Amazon EC2 usage. You decide that you want to stop instances at a predefined time, for example, at night when no one is accessing them. And then you want to start the instances back up in the morning before the workday starts. In this situation, you could configure an AWS Lambda and Amazon CloudWatch events to help you accomplish these actions automatically. Here's what happens at each step in the example. First, a CloudWatch event is scheduled to run a Lambda function to stop your EC2 instances at the end of the workday. Second, the Lambda function is triggered and run with the IAM role that gives the function permission to stop the EC2 instances. Third, the EC2 instances enter the stopped state. Fourth, at the start of the workday, a CloudWatch event is scheduled to run a Lambda function to start the EC2 instances. Fifth, the Lambda function is triggered and run. And finally, the EC2 instances enter the running state. Now consider an example use case for an event-driven Lambda function. Suppose you want to create a thumbnail for each image file that's uploaded to an S3 bucket. To build a solution, you create a Lambda function that Amazon S3 invokes when objects are uploaded. The Lambda function reads the image object from the source bucket and creates a thumbnail image in a target bucket. AWS Lambda has some limits that you should know about. First, Lambda limits the amount of compute and storage resources you can use to run and store functions. Lambda also limits you to 1,000 concurrent invocations in a region. Lambda functions can be configured to run up to 15 minutes at a time. You can set the timeout to any value between 1 second and 15 minutes. There is a 250 megabyte limit on the deployment package size of a Lambda function. A layer is a zip archive that contains libraries or other dependencies. With layers, you can use libraries in your function without needing to include them in your deployment package. Limits are either soft or hard. Soft limits can potentially be relaxed by submitting a support ticket and providing justification for the request. Hard limits cannot be increased. Thanks for watching. We'll see you in the next video.